Okay, for question 14, it says that Ferris wheel with 38 radius and tangential speed of 5 meter per second has 76 kilogram passenger riding it. So the first step, obviously, you have to draw the Ferris wheel. So it says that the radius is 38 meter. The tangential speed is 5 meter per second, and the person has mass of 76 kilogram. What is the magnitude of the centripetal force acting on the Ferris wheel passenger at the top and at the bottom? So they want you to find F at the top and at the bottom there. Okay, so if you want to write down the equation straight away, summation of FC is equals to MAC, which is equals to MV squared over R. Since the V is given, R and M are given as well, so you can straight away use this formula. So you can see that it does not depend on the position of top or bottom. For the FC, it will be the same. So it will be 76, but the normal force will be different. I try to calculate this one first. Over 38. Is it 38? Yes. So 76, 25, 38. 50 Newton at top and bottom. Okay, and then question B, draw the free body diagram showing all the forces acting on the passenger at the top and at the bottom of the Ferris wheel. Indicate whether the apparent weight of the passenger is greater, equal to, or less than their true weight at the top and at the bottom. So basically, apparent weight is actually your N. So basically, you want to determine whether N is it bigger, less, or equal to the weight. So you can show the values for N at the top and N at the bottom, and then you can compare with the values of the weight. But yet, just want you to indicate. But first, draw the free body diagram. Okay, so at the top and at the bottom there, so at the top you can have the weight always pointing downwards. Okay, and then the normal force is actually pointing upwards because you are sitting on the chair. Okay, so the surface is the chair, and the normal force on that person will be N. For that person will be N lah, so the upwards. AC is going downwards, and at the bottom there, normal force still upwards and weight still downwards. The only difference is AC now going upwards towards the center here, right? Okay, so if I want to redraw those free body diagram, at the top and at the bottom, at the top here will look something like this. Weight going downwards, normal going upwards, same goes to the bottom. The only difference would be the AC direction. At the top, AC is pointing downwards, the bottom AC is pointing upwards. Okay, so if I want to write equation for both of these free body diagram, summation of FC equals to MAC, it will be same direction with the weight, same direction with the AC, which is weight, minus the opposite direction, so we weight minus N equals to MV squared over R. And on the right hand side here, which is the bottom, is equals to N, same direction with A, minus opposite direction with A, equals to MV squared over R. Okay, so you want to compare with N with the weight, right? So if N, I write in terms of N, it will be weight minus MV squared over R. Okay, and on the right hand side here is N equals to weight plus MV squared over R. So you can see that for this one, you want to compare N and weight. So weight is on the right hand side here. Okay. and weight doesn't change, obviously. This is the apparent weight. So you can say that N is obviously, because this one, the values for N is weight minus something, so it should be less than the weight. Okay, this one at the top. So you can imagine you are sitting on the Ferris wheel, and if the Ferris wheel, you are at the top position, your N is actually less than your actual weight. So if you want to answer, you can write down like N is your apparent weight, and apparent weight is less than weight. Sorry, apparent weight is less than actual weight. Okay, on the right hand side here is N equals to weight plus mv squared over r. So obviously the values for m is bigger. N is bigger than weight. Okay, at the bottom. You can prove by numbers. I think the next question they want you to determine the normal force. Yeah. So the next question they want actually to find the values for normal force. So here you can find out, and you can compare with numbers. Okay, so question C, I just want to show you the values for weight first. It will be mass times G. Mass is 76 kilogram. So 76 times 9.81. This value is constant, it doesn't change. It will be 745.56 Newton. Okay, so again at the top is over here. Just double check. This one is for the top. Yes, I can use this equation straight away, right? And this equation as well. So it will be N equals to 745.56 minus with mass, which is 76. Velocity is equals to 5 square over 38. And then those values actually we already calculate right before this. So 76, 38. I should get here is 659.56. Okay, so the values for N is less than the values of weight, which is agrees with this statement. Okay, on the other hand, at the bottom here, you have to use this equation. So yeah, N is equal to 745.56 plus mv squared over r. 76 5 square over 38. Again, you can use the values from A actually. Yeah. So I got 795.56. Okay, so plus 50 lah. So you can see here clearly that the normal force is bigger than this one. I mean 759 for sure is bigger than 745. So that one's agree with this statement. Okay. Then the last part, they actually want you to, they want you to find how fast would the Ferris wheel have to go for the passenger to feel double their true weight at the bottom. Okay, at the bottom is basically you can use this formula straight away. Okay, this is at the bottom. So based on that formula, N equals to W plus, I just write down those formula first. N equals to W plus mv squared over r. Okay, so the question we need to find how fast would the Ferris wheel have to go for the passenger to feel double their true weight. So you can say that the actual weight is W, right? This is the actual weight. So they want you to determine the V when N is actually double the actual weight. Okay, 2W. So basically this would be 2W equals to W plus mv squared over r. 2W minus W, I can bring this W to the other side, so you should get W equals to mv squared over r, but this time they want to find V instead. Okay, the weight is mg. We calculated just now 745.56 equals to 78. Is it 78? So the 76 kilogram. So it will be 76 kilogram. V squared over R is equals to 38. So V is equals to 745.56 times 38 divided by 76, take the square root, 19.31. So this one is your velocity needed, so that you have double the weight. Okay, for question 15, they give you a conical pendulum. Okay, so main giveaway for conical pendulum, they might give you the diagram. If not, they will say that it's a conical pendulum, or they might give you an angle. Okay, so you have to be careful a little bit. First of all, you have to identify the circular motion, which is this circular motion. It will be in horizontal plane, and the center of rotation would be this one. So obviously the R radius is actually this R. Okay, and then they state the M is equal to 0.1 kilogram, and the length there is 0.5. So that one is not actually your R, it's the length of the string, which is this part, and then the angle is 70 degrees to the horizontal. So this is the horizontal, and the angle 70 is over here. Okay, so if you do that zigzag with this one, okay, this, because we want to focus on that part. Okay, so once you look at the diagram, you have to identify all the forces. You will have weight in that direction, and then you have tension in that direction. Okay, and then you have to also indicate the direction of AC, which is in that direction. So I just want to redraw the free body diagram. Should have tension in that direction, and then weight in that direction. Okay, and then in terms of the angle, so you have the angle over here, 70 degree, and AC would be in this direction. And obviously you can see clearly the T is not in X or Y axis, so you have to resolve that one, TY and TX. Okay, and other than that, you still need to find the value for R. So maybe you can find the values for R straight away. So this is the triangle. You have this value L. You want to find R, you have this angle. So you can use cos, which is adjacent over hypotenuse. So if I use cos theta, it is equals to R divided by L. So your R is actually equals to, your R is equals to L 0.5 times cos 70 degrees. So your R should be 0.5 times cos 70, 0.17 meter. Everything is in SI unit. Okay, now that you have the R, we can start doing the equation. So from this diagram, just copy, because I'm running out of space. The question was to find tension, speed, and the acceleration. So they wanted to find T, V, and AC. Okay, back to this diagram, you can straight away write down the equation, summation of fx and summation of fy. And since the AC is in x component, so that one would be MA. Okay, instead of x, you write it as C, and for fy it will be equals to 0. Okay, so only one is equals to MA, another one is equals to 0. It depends on the A lies on which component, in this case x component. Okay, so now in that direction we have Tx equals to mv squared over r. On the other hand, for y you have Ty minus weight. So since this one is equals to 0, you just do like upwards minus downwards. So it will be Ty minus weight equals to 0. So Ty is actually equals to T sine 70 degrees equals to weight, which is equals to mg. Okay, Tx is equals to T cos 70 degrees equals to mv squared over r. Okay, now the first question they want to find tension. You don't have the values for v yet, so you can see that you have to solve from this equation. Okay, so let's say I label this one as 1 and 2. So from second equation, my T is equals to mg divided by sine 70. So mass is equals to 0.1 multiply with 9.81 divided by sine 70 degrees. Your tension should be 1.04 be in Newton. Okay, question B, you want to find V. Okay, now you do have the T. You can use this equation and then you can find the V. So from 1.04 cos 70 degrees is equals to mass, which is equals to 0.1. V squared is, V squared over R. R, you already calculate initially there, 0.17. R is equals to 1.04 times cos 70 times 0.17, 0.78 meter. Sorry, this is not R, this is V. But I think I forgot to take the square root. So square root of that. Sorry, this one is already square root. Okay. So it will be 0.78 meter. Okay, and then the last part, they want to find the acceleration of the bob. Okay, so I can do it over here. So you know that summation, you do have the V and R, so you can use this one straight away. AC equals to V squared over R. So it will be 0.78 squared divided by values of R, which is 0.17. 3.58 ms minus 2. Okay, since this one is in SI unit. Okay, thank you everyone.